So you're ready to make the leap, right? You've been building models, you know your stuff, but now you want to design the entire production-level AI systems that actually run the show. Well, you are in exactly the right place. Today we're going to break down how you can think, act, and yeah, even interview like a top-tier AI architect. Let's get into it.
Right off the bat, you've got to understand this role is so much more than just being the best coder in the room. It's really about being a strategic leader. It's about having a vision. And this quote, it just nails it. It's not about rowing the boat anymore. It's about being the one who's steering the ship.
Here's our game plan for today. We'll kick things off with the big picture challenge of the role itself. Then, we'll dive into the core concepts you absolutely have to know. After that, the fun part. We'll architect two real-world systems, just like in an interview, and we'll finish up with the tricky trade-offs and the essential mindset that really sets the great architects apart.
So, what is the big challenge we're talking about? Well, it's this fundamental shift from just executing technical tasks to thinking at a much higher strategic level. You're not just building one machine anymore, you are designing the entire factory. At its heart, your job is to be the bridge. You're the translator between the super technical side and the business side. Let's say the business goal is, we need to reduce customer churn. You're the one who figures out, okay, which models, which cloud infrastructure, and which data pipelines are going to get us there, all while staying on budget and making sure the system is fast and reliable.
All right, let's talk fundamentals. You can't design these massive, complex systems if your foundation is shaky. These are the core concepts that you really need to have down cold. No question about it.
The classic tug of war, bias versus variance. High bias means your model is just too simple. It's underfitting. It's not even seeing the basic patterns in the data. High variance, on the other hand, means your model is way too complex. It's overfitting. It's basically memorized every little detail and all the noise from your training data, which means it won't work on new stuff. A great architect knows how to find that sweet spot right in the middle.
Now, this is a fantastic interview question, and it's a real gotcha if you're not prepared. Just think about it for a second. If maybe 0.1% of all your transactions are fraud, a dumb model that just predicts not fraud every single time would be 99.9% accurate. But it would also be completely useless, right? This is exactly why you have to go deeper than accuracy and use metrics that actually tell you what's going on, especially with imbalanced data like this. All right. This is where the rubber meets the road. We are going to dive into two completely different system design questions, just like you'd get on a whiteboard in a really tough interview. This is your chance to prove you can think at scale.
So here's our first mission. We need to design a churn prediction system. But look at these constraints. 1 billion events every single day. The scale is just massive. And to make it harder, there's 20% data drift, which means the patterns in the data are constantly changing. How do you build something that works not just today, but 6 months from now?
And here it is. This is your whiteboard moment. In an interview, this is what you'd sketch out. You're showing the end-to-end flow, from the raw data coming in all the way to a live prediction that's being monitored. The goal here isn't to get every tiny detail perfect. It's to show that you can see the entire system, the whole big picture. Okay, let's break this down. First, Kafka is like our central nervous system, just taking in that absolute fire hose of a billion daily events. Then, Spark does all the heavy lifting, the ETL, to clean up that messy data. Next up is Feast, a feature store. This is so critical. It makes sure that the features you use to train your model are the exact same as the ones you use for live predictions. This prevents so many headaches. We'll train a powerful XGBoost model on SageMaker and then serve it at huge scale using Kubernetes. And finally, Prometheus is our watchdog, constantly on the lookout for data drift. When it sees it, it fires an alert to retrain the model. See? Every piece has its job.
And every architectural choice has a trade-off. This is the big one. Do you use something like serverless, which is super fast to develop with, or do you go with Kubernetes, which gives you rock-solid performance but is way more complex to set up? Well, if the business needs predictions in under 100 milliseconds, those serverless cold starts could be a total deal breaker. So Kubernetes is the right call here, even with the extra work.
Okay, round 2. Let's switch gears to computer vision. You've got cameras on 10,000 telecom towers, but there's a problem. Your model freaks out whenever it rains or gets foggy. And the business goal? Use this system to make the 5G rollout faster. This is a perfect example of a lab model hitting messy, real-world problems. So how do we build this? Again, Kafka is our starting point, handling that massive video string. We'll use a YOLO model, super popular for real-time object detection, and train it on Google's Vertex AI.
For serving, we're going to use Triton on Kubernetes, which is fantastic for high-performance GPU serving. But here's the clever part. We use Feast again, but this time to fuse our camera data with other data, like real-time weather info. That's how we solved the rainy day problem. All of that feeds into an optimization engine to guide that 5G rollout.
And here we go. This is the money slide, literally. It is not enough to build a cool system. A true architect connects everything they do back to business value. By designing this system, you didn't just make a model better. You saved the company $1.5 million. You have to learn to think and talk in these terms. Always quantify your impact.
So, you've designed this beautiful system on the whiteboard, but now you've got to keep it running in the wild, messy world. And trust me, that's a whole different ballgame. This part is all about the real-world problems that can absolutely sink your project. Listen up, because these are the traps I see teams fall into all the time. Garbage data in, garbage predictions out. A prototype that runs on your laptop just collapses under real traffic. Only measuring accuracy can hide huge problems. And of course, overlooking security and privacy, like forgetting to remove personally identifiable information, is just a complete disaster waiting to happen. An architect plans for all of this from day one.
I love this slide because it shows a really practical trade-off. Let's say you need to fine-tune a huge language model, but you don't have unlimited budget for GPUs. What do? Well, you look at the data. Using a technique like QLoRa uses 4 times less memory and is a bit faster, all for a tiny, barely noticeable drop in performance. This is the kind of smart, data-driven decision an architect makes every day.
Okay, let's talk about the last piece of the puzzle, the mindset. The technology is crucial for sure, but what truly defines a great AI architect is leadership, communication, and an absolutely relentless focus on delivering impact. In an interview, when they ask you about a project, don't just list what you did. You need to tell a story. Use the STAR method, but give it a leadership spin. On that action part, don't just say, I built a model. Say, I led the team that delivered a system which, see the difference? It's about influence and enablement, not just individual contribution.
And this might be the most important skill of all. You have to be able to explain the why behind your decisions in a way the business understands. It's not just, I picked Kubernetes because it's better. It's, I chose Kubernetes because it was the only way to guarantee we could meet that sub-100 millisecond response time that our service level agreement requires.
All right, let's wrap this all up. If you want to think like an architect, here's what you need to do. Always start with the business goal. Master your fundamentals. Design for the real, messy world. Communicate your why. And remember, your job is to lead a team to deliver real, measurable value. That's the whole game.
So, I'm going to leave you with this final thought. It's a question that every single architect faces, probably every single week. The deadline is tomorrow, you have to ship. You can't have perfect performance, zero cost, and immediate delivery. Something's got to give. So, what trade-off are you going to make? And how are you going to justify it? Answering that, that's the heart of thinking like an AI architect.